So students, in the last lecture we had studied about the concentration of ore, means how to concentrate an ore or how to enrich an ore. Okay, that was the second step of metallurgy. That is the second step which we carry. Now in the third step, what we do is we convert the ore into its oxide. Okay, so it is depending upon what type of ore it is, and on that basis we'll be converting it into its oxide. Okay, so this will be the third step of metallurgy, that is extraction of metal from its ore. Okay, this extraction of metal is carried out in different ways. For example, first the ore is converted into its oxide in the first process, and in the another process what will happen, the oxide will be converted into the metal. Okay, so first we'll take the first process, that is conversion of metal, the conversion of ore into metal oxide. Now the production of metal from concentrated ore mainly involves the process of reduction. Reduction process is involved in this, and this can be done by two methods. It can be done by roasting or calcination. Okay, so by these methods we'll convert the ore into its oxide. So first we'll take roasting. This process involves the heating of the concentrated ore strongly in the presence of excess of oxygen. So we'll heat the ore in the presence of oxygen, and the oxygen should be in large amount. Okay. This process is generally used for converting sulfide ores into its oxides. Okay, so we use sulfide ores and these are converted into oxides. So we'll take some example to understand this process of roasting. For example, we take a sulfide ore such as FeS. Then in the presence of oxygen, which is in excess, there will be formation of an oxide. Now it can form ferric oxide, that is Fe2O3, and here liberation of SO2 gas. Okay. The ore we have used, that is FeS, we call it as iron pyrite. So when we heat iron pyrite in the excess of oxygen, then it will get converted into its oxide and liberate SO2 gas. Over here, oxygen is added and sulfur is removed. Okay. We balance the equation. Similarly, we can take another example of sulfide ore, that is zinc sulfide, ZnS. We also call this as zinc blende. This will be also heated in excess of oxygen and it will form ZnO, that is zinc oxide, and liberate SO2 gas. Initially ZnSO4 is formed, which further breaks down into ZnO and SO2. So in both these processes we can see what is happening is the metal ore is getting converted into its metal oxide. Okay. Now roasting is used for sulfide ores because sulfides, they easily get converted into SO2 gas and they give the metal oxide. Now what is the use of roasting? Generally, by this method of roasting we can remove the excess of water if it is present in the ore or the ore is hydrated. Secondly, volatile impurities can be removed. Okay, and the third and not the least is the metal is getting converted into its oxide. The ore is getting converted into its oxide. So this was about roasting. Now we'll take the other method, that is by calcination. Calcination, in this process, the concentrated ore is heated in the absence of oxygen. Okay. Now the type of ore, that is carbonate ore, which shows calcination, that is carbonate, they easily decompose into metal oxide and liberate CO2 gas. Okay. So we can say for carbonate ores generally calcination is used, and for sulfide ores roasting is used. Difference between both is roasting takes place in the presence of oxygen and calcination occurs in the absence of oxygen. Now here we will take some example. For example, zinc carbonate, that is ZnCO3, called as calamine. When this is calcinated, it forms ZnO plus CO2. Here, carbonate ore of zinc is converted into its metal oxide. Another example is FeCO3. It is also calcinated to form FeO plus CO2. Iron carbonate is called siderite. Similarly, calcium carbonate is also heated and it will also form calcium oxide, it is quicklime, and CO2 gas. Okay. So in this way we can calcinate any ore and we can form the metal oxide if that ore is a carbonate ore. Now in both these steps, what are the changes observed? In both roasting and calcination, we will take those changes. Changes which occur in roasting and calcination. The first change is ore, which is concentrated, it's getting converted into metal oxide. Second is moisture and hydrated ores lose their, and the third change which occurs is volatile impurities are removed. Why they will be removed? Because when you are heating, during that process, if the impurities are volatile means they get converted into vapors very easily, then what will happen? All those impurities, they will go away from that system and in this way they will be removed from the ore. Okay. So these are the changes which are involved in roasting and calcination.